Calcium is one of the secondary nutrients needed by plants. And in fact, calcium is needed in very large quantities, probably almost as much so as nitrogen is in the macronutrients. We don't typically worry about calcium a whole lot in the Midwest because about 3.6% of the Earth's crust is calcium to begin with. And we do usually a pretty good job of trying to maintain the pH of our soils. And obviously, if your pH is where it needs to be between 6 and 7, you should have enough calcium present in your soil to supplement the plants. Because calcium is one of the bases, when we talk about the four major bases due to cation exchange, which would be calcium, magnesium, potassium, and sodium, calcium makes up the biggest percentage of those four. So therefore, there's usually lots of calcium in our soils. There's more probably calcium the deeper you go in the profile because the subsoils have a lot of clay content as well, and obviously still have some cation exchange capability. So again, there's a lot of calcium in our soils, and it is one of the essential elements for plant growth. And we like to have a lot of calcium present in our soil because it helps build soil structure and obviously it helps regulate the pH of our soils. So that's pretty critically important to growing plants. In fact, pH is probably one of the number one things you need to correct in your soil if you want to maintain a healthy plant. Just like calcium is used in your body to help build strong bones and a good solid foundation, it's kind of very similar in a plant. Calcium is used for the cell walls, for protein synthesis, cell division, cell elongation, so basically growth within the plant, which helps then build stem and straw strength and all those kind of issues you'd affect with the plant being upright and strong and maintained well is due to calcium. It also is pretty big in protein synthesis, the regulation of carbohydrates, and it also helps influence water movement within the plant and between cells through cell walls and cell membranes. Another big thing calcium does is obviously regulate the acidity within the cells, just like it does in the soil with regulating pH. It does the same thing within the cells individually, as well as in your own body and your bloodstream. But calcium also aids in cell permeability, so being able to move moisture across membranes. Calcium's a big player in that. It's also an antagonist for other ions. So like if a plant's trying to take up some other nutrients, calcium might be part of that process, as well as calcium helps tie up things that might be toxic to plants as well. And it's also very critical in grain and seed formation, as well as aids in nodulation of legume type plants. We typically don't see calcium deficiencies in the Midwest. If you do, it'll probably be in a greenhouse situation or a place where you're using maybe an artificial growth medium. But out in nature, we rarely see it just because of all the calciums in our soils and as long as you're maintaining a good pH. But if you do see it, calcium is not very mobile in the plant, so you're probably going to see the deficiency symptoms in the newer growth. It's going to can appear in many different ways, but usually it's just crinkled or curled leaves. The leaves curl up or curl down. They can have some excessive green color because they'll accumulate nitrogen because calcium helps nitrogen convert to protein. But again, those are pretty critical symptoms you'll see is that leaf curling, and sometimes you'll see some browning and some stuff like that happen too, but it's usually just a leaf curling situation. Again, typically just to rehash this, if you're going to see a deficiency symptoms, look around the edges of the leaves, the margins of the leaf where they're curled up, or maybe they didn't even unfurl correctly. So if the terminal leaves are coming out, don't unfurl correctly, that's another indication of calcium deficiency. But again, probably not going to see it out in nature. But plants take up calcium in just the calcium anion, so calcium plus 2. We get, again, we don't really see deficiencies much because we have lots of calcium in our soils. And obviously, if we're maintaining our pH, we're putting limestone on, or dolomitic lime is very two common sources. And so therefore, that tends to have enough calcium in our soils. So we usually don't see those deficiencies very much in nature. Some people are starting to use gypsum as a soil amendment. And there's kind of a misnomer out there that gypsum will affect your pH, but it doesn't because it's actually calcium sulfate. So even though the calcium would be, quote, making your soil become more neutral, the sulfur will counteract that. So it's pretty much just a neutral product as far as pH is concerned. Typically used to see it a lot being applied in arid soils, more in the Southwest, I guess, but it is becoming more popular around here as a source of basically being able to supply calcium and sulfur at the same time and not really change the pH much. So you might see more use of that here in the future. The next several slides are going to show you some deficiency symptoms that you could see if we would ever see it. But again, it's a rarity that we're going to see it out in nature. But here's an alfalfa plant showing you, you can see how the leaves maybe aren't as big as they should be on the picture on the one on the left there, as well as you can start to see some of that kind of yellowing on the margins Not really curling going on yet because it's early symptoms here, and this is a pretty small leaf to begin with. Here's a beet plant showing calcium deficiency. As you can see, this is one of the symptoms I talked about earlier, where you can see the terminal leaves coming out of the new growth there. They're not unfurled correctly. They're all kind of crinkled up, not distorted. That's kind of a classic sign of calcium deficiency within some plants. This is the one calcium deficiency we do see in the Midwest fairly frequently. This is called blossom end rot of tomatoes. And it's not that there's not enough calcium present in the soil, because there is. It's the fact that tomato plants are very sensitive to environmental changes. So go from cold to hot, hot to cold, wet to dry, dry to wet in rapid succession or something like that. Just a lot of increase, a lot of variability in environmental conditions causes blossom end rot to occur. And even though you might think that's a disease, it's actually a calcium deficiency causing that. So if you want to not see that condition happen, make sure your tomato plants don't see extremes. So maybe put mulch around the outside plants around your tomatoes so the soil temperature stays more consistent. If we're going into a dry period, maybe give the plants a little water. But again, don't get excessive in anything. Don't get too dry, too wet, too hot, too cold. And you'll rarely see blossom end rot within tomatoes. Here's an English holly plant showing some deficiency. And again, it'd probably be growing in some kind of a artificial growth medium. You can see some black spotting there, some brown spotting on the leaves. The margins starting to look a little goofy. Again, all part of calcium deficiency. Here's probably more typically what you'd see in a greenhouse situation. This is a poinsettia plant showing you kind of that curling of the leaves, and the edges kind of starting to turn brownish a little bit. But again, that curling leaves is probably a very classic symptom that you would see. And again, it's probably going to be on the newer leaves, not the older ones.